Hey guys, in this video we're going to talk about how to figure out if two linear functions are parallel, perpendicular, or neither of the two without graphs. Okay, let's get started. Let's take a look at the anatomy of a linear function. In this case, we're going to focus on intercept form. I covered this also in my previous video, which I butchered a little bit, and we're going to have to focus on the slope-intercept form again. So, when we look at this y equals mx plus b, we have to remember that m is for mountain or slope. Then b is for y-intercept. Now, we don't focus too much on the y-intercept. We focus more on the slope. And what we want to know is when we compare two linear functions, if the slopes are equal or not. So we could tell if two lines are parallel without graphing if the slopes are equal. If the slopes are negative reciprocals, and I'll go into that in one of the examples, then the lines are perpendicular. Alright, let's take a look at the first example. So in this first example, I was pretty generous to myself. And this first equation here, or this first linear function, is already in slope-intercept form. In fact, all I need to do really is just to place a 1 under this 3 so that the slope is in the form of a fraction, and I'm done here. On the other one, I have to convert that to slope-intercept form, and it's pretty close. So all I have to do here is get the y by itself, so I'm going to divide out this 2 to all three of these terms. This 2 divided by 2 becomes 1. So 6 divided by 2 is 3x minus 3. Okay, just like before, I can put a 1 under this 3 and make the slope. So let's take a look. If you look at the slopes here, both are 3 over 1. So the slopes are equal. That means that these lines are parallel. We don't really worry about the y-intercept. In fact, it doesn't even matter what that number is, because all we want to know to answer the question is what the slopes are. Let's take a look at the next example. Okay, we're getting a little bit trickier here, but just remember the rules. The rules never change. So I have to get y by itself. I'm going to subtract this 8x to both sides. That's going to give me 0 on that side. On this side, these two terms will not go together because they're not alike. So I just bring that over. Now what I'm going to do, I made a little bit of a mess here, let me clean that up, is divide this -2 to both terms. And then I'm going to get positive 4. I'm going to put a 1 under it, just thinking ahead, because I know I want it in the form of a fraction. Now here, 3 and 2 don't divide either. And to be honest, for the sake of this problem, and this is one of those things we got to learn as we get more experienced in math, I don't really care. So I'm just going to leave that a fraction too. Alright, let's take a look at the other. Okay, I'm going to subtract x to both sides here. In this case, there's no number in front. Remember, that's a 1x. I'm going to subtract that x to both sides. And that's going to give me x minus 1, or negative x minus 1. Now, technically that's a negative 1x, and that's important to recognize because when I divide by 4 here, there's a 1 in front of that x. So I could write this way, which is really helpful when it comes to determining if these lines are parallel or perpendicular or neither. Again, just as I mentioned before, I don't really worry about the y-intercept, so I'm just going to leave it as a fraction. It's not like I'm graphing this anyway. Okay, so let's take a look at this one. These two slopes are negative reciprocals of each other. What does that mean? It's actually a very loaded topic that often early math teachers or math teachers in early grades make light of. And I'm not going to go into it here, but the word reciprocal is very intentional. For the sake of fractions, what we need to understand is that the reciprocal of a fraction is the fraction flip. When we look at negatives, when we say negative reciprocal, what we're saying is that the sign changes. So, if it's a negative 1 over 4, the negative reciprocal of that is 4 over 1. It's kind of the reason why there's a specific word here instead of this saying opposite and flipped. Okay, it's much deeper than it appears. So, with all of that being said and out of the way, these two slopes are negative reciprocals of each other. One is 4 over 1, and the other one is negative 1 over 4. So that means that these two lines will intersect to make a right angle, or that they are perpendicular. Alright, let's take a look at the last example. Okay, the same as I have in this video and the previous one, I'm going to follow the same algorithm. And what that means is I'm going to use a series of steps that are always the same to isolate y or get y by itself. So I'm going to subtract 3x to both sides. 3x minus 3x is 0. So I have 2y equals, that should be an x, negative 3x plus 5. Then I'm going to divide by 2. And I'm going to have negative 3 over 2x plus 5 over 2. As we move into more advanced math, get used to these numbers in the form of fractions. More advanced math actually moves away from decimals quite a bit because decimals are not precise. Okay, going to follow the same process here. Subtract the 2x to both sides. That becomes 0. 3y equals negative 2x minus 3. Then I'm going to divide by 3. I'm going to have y equals negative 2 over 3x minus 1. Alright, let's take a look at what okay, so this is where attention to detail really matters. And this is where you have to really slow down and think about what you're doing. While the fractions are reciprocals of each other, they are reciprocals because this one's 3 over 2 and the red one is 2 over 3, so they are flipped. They are not negative reciprocals, and the reason for that is because both of these fractions are negative. You have to be really careful here. So these fractions are not negative reciprocals. As a result of that, because they don't fit exactly the two conditions that dictate if we know a line is parallel or perpendicular, we know that these lines are neither parallel or perpendicular. Okay guys, I hope you guys have found this video to be helpful.